So if you have not noticed already, I loaded a new module to the Canvas. So for all of you who have your laptops here or your phones or whatever, let's go to the Canvas and see if we can get registered in the Mastering Physics. Now, my last class had an issue, but this one may not. So let's see. And I would suggest going through the Pearson link first. So you should, let me see if the Pearson link's up. Modules. Oh no, they're not published. So you should be able to, now you should be able to see them. So if you can't go through here, click on Pearson course materials and then try to get registered that way. If not, then we could try the student registration handout. Try that way. So inside of this is important for us to get done because inside of this is going to contain your textbook. All right. And you cannot take a physics class without a textbook. If you do, then it is a joke.
Which option do we choose? Verify enrollment?
What are the options? All options.
You have trial access until January 31st, enroll, or you can verify enrollment. Like, that's the three options there.
It said access until January 31st? No. And you said trial? No. And then what was the other one?
It's like enrolls his contact support to gain full access, and you view your options, or you can verify enrollment.
Verify enrollment.
It's not working.
What did it say?
It says invalid information. It said I'm not enrolled in my campus access.
Okay.
Is there a code?
No, they don't give us the codes anymore. That's supposed to be already on the back end. And the same thing? Yeah. All right, well, I gotta try that again. All right, but nah, we used to get codes, but they stopped that. They stopped giving the codes, and they integrated it to the learning management system. So once I set it up through the learning management system, you should be able to access it. And just like everything else, y'all have mastering chemistry and all that other stuff, right? Y'all didn't have to put in a code for that, right?
No, my person has been working. So they told me to go to the book.
I think it's something with Pearson itself because Wayne said the same thing.
Who said the same thing?
Oh, you probably know why.
Oh, okay.
She teach you.
Okay. All right. Well, we'll see. I'll see. All right. Well, we'll work on that, but that don't stop nothing. All right. Let's see. So let's see if I can do this. All right. So then let's just do this then. All right. So I'll just start with some quick things about what we're gonna be doing. Okay. All right. All right. So everybody in here is familiar with scientific notation, right? Yes? No? No? Did it before? All right. So, So what is scientific notation? What's the point of scientific notation? Like, what is it? Why do we need to learn it? Why is it important? Why do y'all think it's important?
What you say to the
Numbers too
zeros,
long to write out.
with all the repeated numbers, maybe?
Yeah. You say, what about it? What about the numbers? What about the numbers?
Repeating?
Well, yeah, they're repeating. Yeah, there's a lot of zeros. Yeah, but what about them? I'm saying, why is scientific notation important?
Because it's infinite, the numbers don't stop infinity.
Well, the numbers can be very large, and there's a lot of zeros. So what happens when you have a lot of zeros?
It complicated.
Huh?
It gets complicated.
And mistakes happen, right? So if I tell you a number, speed of light. Speed of light is 3 times 10 to the 8th meters per second square. All right. Now, if everybody in here looked at that number written out with all the zeros, some people are going to see 9 zeros. Some people are going to see 7, depending on who you are, what type of vision you got. We're all human beings. It's called human error, right? Some people are going to see more than 8. Some people see less than 8. So to eliminate that confusion, or that possibility for confusion, we write numbers in scientific notation, right? So we can write the number 10, right? And then we add an exponent to it. So what is so significant about the number 10? Anybody? Why is 10 a significant number for us? Huh? You ever thought about that? Why is 10 a significant number? It's a significant number for us.
I know you can multiply, divide, and even and stuff like that. It's something else.
Well, yeah, right? So, our number system has how many numbers? 10. Our number system has 10 numbers. Every number in our number system is composed of those 10 numbers. So we start at 0, then we count to 9, and then we do what? Start over at 10. 10 is us starting over at 0, right? We just added a 1 in front of it. And then when we get to 19, we add a what? 2. So 10 is a significant number in our number system. All right, that's why we call it base 10. Okay. And so if you looked at, you can look at any one of them, but I draw your attention to 45,000 right there, right? So 45,000 written as written in scientific notation is 4.5 times 10 to the 4, right? And so 4.5 is what we call what? What do we call 4.5? What is that? Huh? No, not coefficient. Right? They're called significant numbers. What does it mean to be significant? Yes, it means to be important. Yes, that's what that means, right? But in mathematics, what that means is the numbers here, right? In this case with 45,000, 4.5, these are the numbers that will have the most impact on whatever it is you're calculating, right? Because that's what we're going to be doing, calculations. We're going to be We're gonna be calculating numbers, and those numbers are gonna be very huge, right? And very small, right? Can anybody give me an example of a very large number?
4 trillion.
Tree.
Okay, well, how do we write 4 trillion in scientific notation?
I don't know how to do that.
Okay, well, give me a number we can write in scientific notation.
You can do 1 million.
456.
Or 4,000.
Just do 1 million.
1 million?
1
Okay. What's 1 million in scientific notation?
1 times 10 to the 6.
6.
1 times 10 to the 6. Right? Because 1 million has how many zeros? 6 zeros. Right? So if we look at 45,000, right? When we write 45,000, we can also write that as what? 4.5 times what? 10 to the 4, which is what?
45,000.
Huh?
You said 45.
What is 10 to the 4?
Oh,
That's 10,000.
10,000. And how do we get 10,000?
10 times 10 times 10 times 10.
Okay. Okay. All right. So 10 times 10 times 10 times 10 gives us 10,000. And we multiply 4.5 times the 10,000 and we get 45,000. Right? So that's a big number, right? Relatively big number. Okay? So for us, a relatively big number is like the speed of light. Anybody know what the speed of light is? 3 times 10 to the 8 meters per second. Okay? Anybody take chemistry yet? Are we familiar with Avogadro's number? Yes. 6.023 times 10 to the 23rd. What is that, though? That was you?
Yeah.
What is the Avogadro's number? See, that's important, right? That's important for us to know. See, that's a lot of times, that's our problem. Let me just stop here and say that, y'all. That's our problem. A lot of times we know things, but we just don't know what they mean. Yes. That means that any mole, 1 mole of any substance, 1 mole of any substance has that many particles. Atoms or particles or whatever. Okay? So it's a way for us to put a weight, a unit of weight on something that is we almost can barely see with our eyes. Right? Because when you go in there and you deal with the powder, they say, all right, well, put 2 moles. And you got to do a little calculation to figure out how many grams that is. Right? But that's just a unit of measurement of weight for small things. Very, very, very small things. Like particles, atoms. All right? So we deal with things that are very, 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 very small. All right? So I just told you a number that was very, very big. Actually, the mole, the number of moles, the number of particles in the mole is a big number. But the mole itself is actually a small thing. It deals with small things. But it's a big number. What about a small number? Can anybody think of a small number? What's a small number? Huh?
Negative 1,000.
Well, yes. So think about something in nature which is very, very small. Right? So let's go away from the mole, right? So if I told you the weight of the earth, how much the earth weighs, that would be a what? A huge number. 6.31 times 10 to the 31 kilograms. 31 zeros. Imagine having to write that number. 31 zeros. Okay? So that's a huge number. All right? What about a very, very small number? Anybody?
The space, I don't know. Well, it's big, but it
What space? What space? You said space. They got a lot of different spaces.
you right. The cook, that's small.
No, not, because you can see that.
Yeah.
You can see that cup. When I say small, I mean small.
A cell?
Yeah, like coronavirus,
Oh, okay.
COVID. You can't see it, but it's everywhere. But you can't see it because it's just that small. But it's here. Obviously, right? It's everywhere. Bacteria, right? We go even smaller. We talk about atoms and electrons, right? Nuclear bomb and stuff like that. We're talking about small materials, okay? In very small spaces. That's why they create so much energy like that. But anyway, all right, so we're talking about very large numbers to very small numbers. So from one end of the spectrum to the other end of the spectrum. So that covers the entire world. So physics is the study of the entire world. Right? Most people think about physics as just astronomy, as studying planets and stars and all of that. Well, what about the nuclear physicists who create the atom bombs? They deal with things that are not very big, but they're very small. That's why they have so much energy and why they could be so destructive. All right? So that's why it's important for us to understand how to handle scientific notation. Right? So my question for you now is, what does it mean when we move the decimal spot? The position of the decimal spot. All right? What does that mean? What does it mean when I move the decimal spot to the right?
It gets smaller. Wait, it get larger. Get
Larger.
Yeah.
I get larger. I add zeros.
Mm-hmm.
Right? So if I'm moving to the right by 3 decimal spots, then I just multiply by what? Huh? 1,000.
Because it's 10, 100.
10 times 10 times 10. Right? And so if I move 3 times to the left, that's what? Dividing by what? 3 times. Well, you're not dividing 3 times. You're dividing
1,000.
by 1,000. Okay? You're dividing by 1,000. So in one instance, we're doing what?
Multiply.
We're multiplying by 1, 0, 0, 0. Then the other instance, we're multiplying by 0.001. That's 1,000. That's 1 over 1,000.
The 0.00.
2 zeros in front of the 1. 3 spots, right? From 1, going to the left. That would make it 0.001. That's 1,000. Okay? So like I said, so like what I tell my other classes, right, is that I'm not a micromanager, right? So I'm not gonna check to see if you're practicing or you're doing what you need to do. I'm not gonna do that. All right. The most I'll micromanage is probably the attendance, and that's because they make us do that now. If they didn't make me do that, I wouldn't do that either. Okay? But, so, I said that because it's gonna be up to you, right? Because what happens is, a lot of times, we get in here and the only time we do this stuff is when we're here with me. All right? And so, it's like I tell, it's like if I go if I'm putting the floor down and I got a guy who's been putting floors down for 30 years, I got him helping me, right? It's gonna seem like this is nothing. This is child's play. But the moment I get in there by myself, right, and I run into the first problem, right, then the ball game changes, because I can't go ask nobody then. That's how it's gonna be on the exam, right? So what you want to do is you want to get that experience out of the way ahead of time by spending as much time with this material as possible. Then you're gonna know, well, what is it that I don't understand? I can ask him. When we get to class. Okay? But if you don't ever spend time with this material outside of class, right? I'm telling you, outside of class, right? Because like I said, I've been doing this a long time. Okay? So it might be deceivingly simple. Okay? And it's definitely gonna be that way with the content when we start doing physics. If you don't do it without me, then the likelihood of you understanding it is gonna be minimal to none. You gotta do it without me. I'm just telling y'all that. You gotta do it. You gotta bump your head. You gotta go home, bump your head. I'm telling you. I've done it many a time. That's why I'm standing before you now. Because I have bumped my head many a times. Okay? So you gotta do it. And sometimes it's painful. And it hurts. But you gotta do it. And there's been many of you that's passed this class and graduated from this university and went on to do great things. So it's gonna be plenty of more. So don't feel sorry for yourself and say something about math ain't my whatever. I don't like math or whatever. It's a lot of people don't like math, and it's a lot of people that's finished this class and went on to do whatever it is they want to do. So that's an excuse. Okay? All right, so 12:38. All right, so all right, so let me spend some time with the mastering physics and try to get that situated, because inside of that software you're gonna have a textbook, an e-text. That's where your textbook is, inside of the software. Okay? So you have a textbook. It's in the software. You have to go in the software and download it. Okay? Yes.
For my other classes, they were saying we might have to go to the bookstore and just show them that book class again, so they can fix it.
Oh, yeah. That might be. That's something above my, you know what I'm saying? All I know about is physics. That's it. Like, that's probably an IT. Cause they do all that. The IT people do all that. You know what I'm saying? Like, I don't control none of that. Like, I don't even really know about that stuff. All I get an email at the beginning of the semester. It says set up your courseware, and I do it. I follow the instructions, and it never works. Never. So, not the first time, at least. Never works the first time, I should say that. Like, I always got to go do something, call somebody, do this, do that, and then it's going to work. All right? So just give it a little time. By next week, we should be going by next week. Definitely going. All right? And so, also, all of my lectures are recorded. Okay? And I'm going to put that recording on the Canvas page. All right? So, So if you miss a class or something like that, then you can look at the Canvas page, right? The reason why I do that is because, number one, you know, folks like to cook up things and make up stories and come up with all kind of reasons why we're not performing like we should, right? So, in order to protect me, right, then I'm going to record all of the classes, right? So, towards the end, nobody can claim that Dr. Stewart missed these many classes. Dr. Stewart didn't do this. Dr. Stewart didn't do that. Because it's all recorded. And I got them. All right? And they on the Canvas page. All right? So it's a benefit for me and you. So like I said, if you miss class, that's fine. Right? Don't kill yourself. Because you can catch the recording on Canvas. All right? So, particularly after I have reported, we have gone through the reporting period for financial aid. Okay. So once that's done, then, like I say, if you miss a class, if you got something, I understand things happen. Right? But, you know, I get it. You know, sometimes students don't like to give me that same grace. So that's all right though. That's fine. That's why we're gonna record everything, and it'll be on your Canvas page. So that way, nobody can say anything. All right. Any questions for me? Yep.
Basically, I'm trying to see if you can see if whatever Mr. Shun, whoever it is, I know y'all.
Mr.
know
who?
Sean.
Sean, the lab teacher.
Yeah, I don't know.
Oh, so how did lab go? Did I go to lab? He didn't show up?
He said no class for the whole week.
Oh, okay.
Yeah,
Yeah, that's
they
him.
don't have a class.
Oh, they don't have all that.
Yeah,
Okay,
I was
yeah,
gonna
yeah,
ask you
yeah.
to see if you could ask him or whatever.
That's his class.
He
I don't
said,
know, yeah. I don't know nothing about that.
okay, that's all.
Yeah.
You have a nice day.
All right.
You know where his office is?
Well, right now it's on the first floor, but you know they about to tear it down, tear the building down. So go ask him and you know get his email or something so you can keep up with him. Everybody sign the roll.
I don't know if the other two girls should have like 9. All right, Mr. Stewart.
All right.
See you Friday.
Yes, indeed.